Hey, ladies and gentlemen. So today we're going to be working on not just electron configuration, but we're going to add one more part to it, an orbital notation. So orbital notation gives us a little bit more because electron configuration tells us the energy level in the orbitals that our electrons are in. But orbital notation will give us a complete address of our electrons, because not only will we know the energy level, we'll know the sub level that we're in. So if we're in the S of the P block, the number of orbitals that it's going to have, so the number of sections that it'll have, and we're going to know how the electrons are spinning. So there's going to be up and down spins that we're going to have to talk about, and we'll see when we do our practice together. Right? So there are three rules that we need to know in order to understand orbital notation. The first one is going to be our Aufbau's principle. And Aufbau's principle is telling us that we're going to fill the lowest energy level first, okay? Which should make sense in our heads, yet it has to be stated, or else we might not remember to do so, and that could be an issue. Okay, so remembering that the lowest energy level is filled first. That just means we start with 1s and work our way up to 7p. All right. We don't start with 6p and hope for the best. We always start down at 1s. Okay. We should have started with that yesterday when we just did our electron configuration as well. So it's something we've been practicing anyway. We just need to remember to keep doing that and to do that every time. Okay. And so then our second one is going to be our Pauli exclusion principle. And our Pauli exclusion, it states that if there are two electrons in the same orbital, then they have to go in opposite spins. And so, well, let's write that down, and we're going to actually see what that means in a second. But that just means that if one is spinning upward, the other one's going to be going in the opposite direction, so down. Okay, and we'll go through what that actually means in just a second. But for now, let's make sure to write down that two electrons in the same orbital must have opposite spins. All right. And then our third one, Hund's rule. Hund's rule states that we must fill each orbital with one electron before we go back and fill with a second. And so you'll see in a minute that some orbital or some sublevels will have 3, 5, or even 7 orbitals to fill. And so when we talk about it must fill one, if you're in the sublevel that needs 3 orbitals, we have to fill one in each of our 3 before we go back and fill a second one in each of our 3. In sublevels with multiple orbitals, we must fill one in each before doubling. All right, so again, we have to fill one in each before we can double up with a second one. Okay. So if we look at nitrogen, nitrogen is number 7 on the periodic table. So we have 7 electrons. And so if we go through, remember, hydrogen always starts with 1s. Hydrogen and helium are our first 2, and we go through both of those to get to nitrogen. So we have 1s2. And then we keep going, and we go to 2s, and we go through both lithium and beryllium to get to 2s, so 2s2. And then we keep going to 2p, and then we go 2p1 is boron, 2p2 is carbon, and 2p3 gives us nitrogen. So we have our electron configuration. Now our orbital notation. So each line is going to count as an orbital. So we're going to draw a line for 1s, and each line gets a maximum of 2 electrons in it. So I'm going to put one arrow going up, and just so you guys see my arrows look funky, you can draw normal arrows. I was just taught in college to draw them as half arrows just to make life easier, so they didn't have to take up as much space. But so these are my arrows, but if you want to draw normal ones, you are more than welcome to do so. Okay, so you can draw them going up and going down. They are the same. You just won't see mine look that way. So then we go to 2s, and we go 2s, and we put 2 electrons in 2s, and then we go to 2p. No matter what, anytime you draw the p block, or the energy sublevel p, we need to draw 3 lines. And I'm going to move mine a little closer just so we all know they all belong together. But this is all my 2p section. So you can write it like that if you want to write 2p under all 3 of them. And so this is where we talk about Hund's rule. Okay. If we have 3, we need to put 1, 2, 3. We can't put 1, 2, 3 like this. Okay, we never want to, if we have the opportunity, we never want to leave one completely empty. We always want to fill each of them first with 1 before we fill a second one. The other thing is the Pauli exclusion principle. Okay, we never want to have both our electrons going up. Okay, so we never want to see 2 arrows going up or 2 arrows going down. We always want to have 1 of each going in each of our orbitals. All right. Okay, so now we got to look at the next. And the next one is technetium. And so that's element number 43 on your periodic table. So the number of electrons should be 43. So if we go through that one, we end up through 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And remember, after 4s2, so after calcium, when we get to strontium, sorry, not strontium, scandium, and titanium, and all of those, they go back down to our 3D, and we can count there are 10 elements in 3D. And then we keep going back up to 4p, 6, 5s2, 4d, 10. And this one is going to be a doozy to draw. So let's get started with our 1s2. We have 2 electrons, one going up, one going down. Then we go 2s2. So 2 electrons, one going up, one going down. 2p6. So 3 lines for 3 orbitals. So 2p, we go 1, 2, 3, 4, 5, 6. And we go 3s2. 1, 2, 3p6. 1, 2, 3, 4, 5, 6. Then we go 3, 4s2. 1, 2. And then we gotta go 3d10. So because only 2 electrons can fit in each orbital, we need to draw 5 lines. One, two, three, 4, 5, 6, 7, 8, 9, 10. And I just realized I made a huge mistake. So go back right real quick. It shouldn't be 4D10 because that would be all the way at the end. If you guys look, it's actually only at 5. So it should be 4D5. I apologize right now. It should be 5. And that was 3D10. Okay. Now I'm running out of room. So I'm going to go down below to get to my 4P. 4P6, that means I need 3 lines for 4P. And we go 1, 2, 3, 4, 5, 6. And then we go to 5S2. 1, 2. And 4D5. Remember, we need to draw all 5 of our lines. 3, 4, and 5. 4D, and we put 1 in each of those lines to show that 1 gets filled first before we go back and do the other ones. All right. So now you have some practice. Remember, you need to do both the electron configuration and the orbital notation for these. So there's not room to split them up like there was before, but you're going to do both of them down below. And then just go through and identify which rule is being broken in the last section. Again, if you have any questions, please send me any messages if you need anything. Otherwise, check the answer key, or you can ask Miss Dabney if she's in class, or you can wait till tomorrow when you see me again. All right, have a good rest of your day, and I'll see you guys on Thursday.